Hi again, Pre-Calc. The purpose of this video is to show you the answer to this homework problem that you were given yesterday and go through that a little bit. I'm going to show the answer first, so if you got that, you don't have to watch the rest of the video. Here we go. If you got this answer, it's the same answer either way you look at it. This is the way that I do the problems. This is the way that Sam suggested to do the problems, which has been working for me, so I say go for it. There we go. So we have the three intervals here: negative infinity to -1, non-inclusive; -3/4 inclusive to 3 non-inclusive; and then the final interval 4 inclusive to positive infinity. There we go. So if you had that answer, you can stop watching the video. If you did not have that answer, keep watching the video. Here we go. If you solved it the way that I solve it, which is getting the 6 over, finding a common denominator, setting the whole thing equal to 0. That's that process there. I ended up foiling both of these guys, combining like terms, and I ended up with a quadratic. Now, because I did have a quadratic, I factored it. If it had been linear, I wouldn't have had to do that. It would have been easy to solve to figure out when does the numerator equal 0. When is it positive, when is it negative? But because it is quadratic, I have to factor it. And I factored out a -1, which isn't necessary. I just don't like dealing with a negative x squared piece. So that's why I did that. And that actually requires another step later. So let me show that real quick. There we go. So what that did was I had to consider the first part of the numerator, the second part of the numerator, and then once I considered both of those together, I had to multiply the whole thing by -1 because I did have that -1 out there. Then I had to consider the two pieces of the denominator. They both get their own number lines too. So I ended up with 4 different number lines, but then I had to consider the top two pieces with the -1. All in all, again, and I wrote this at the top here, let me slide right here, multiplying and dividing with negatives and positives are the same because it doesn't matter if we're multiplying or dividing. As long as we have an even number of negatives, I am going to get a positive. If I have no negatives, I get a positive. Even numbers, I get a positive. It's when I have this one lone negative that I end up with a negative. So let's consider some of these. If you need to look at this farther, you can pause the video and take a look at that. But let me just go through one real quick. Let's say I am to the left of -1. I see that in my numerator I am negative. My second part of the numerator I'm also negative. Together they make a positive, but I have to multiply by -1. So the whole numerator is now negative. In my denominator I have negative and negative as well. They make a positive. So negative numerator divided by a positive denominator ends up with a negative overall fraction. So I just did that piece by piece by piece by piece as I went along. Now, real quick, let's go over to the method that Sam suggested, which is, what if we just consider the restrictions to the domain? In this case, it is +3 and -1 are my restrictions. When I go to solve the rational equation that results there, I would multiply the left and the right sides by the denominator to cancel it away. That gives me with the x plus 2 and the 2x minus 3, when I FOIL it, I get over here. When I FOIL with the 6 and the x minus 3 and the x plus 1, I get this piece over here, eventually this piece once I distribute the 6. Combine your like terms, excuse me. You eventually have to get it equal to 0 anyway. Because it is quadratic, you have to factor it, but the way I moved my pieces around, it wasn't negative this time, because I just moved everything to the correct side. So you factor it, you get your two pieces, so you have to consider, when is it a domain restriction? When would the whole thing give me 0? Here. So those are my four numbers that are important. And then you also have to consider, get my marker out here, so not only those 4 locations, remembering that these are domain restrictions at -1 and 3, so I cannot actually use those numbers, but at 3/4, I need to know if I am 0 or not 0. At 4, I have to know if I am, well, sorry, not 0. In this case, I'm testing if it gives me 6. That's the key. I need to be less than or equal to 6. So I tested numbers to the left of -1, between -1 and -3/4. I tested -3/4 exactly. I tested between -3/4 and 3. I tested between 3 and 4. I tested 4 exactly. I tested above 4. So in the end was 7. I had to test 7 different pieces there. So that's a bit of a hassle there because I need to know exactly where they fall around 6. But in the end, you see you get the same exact answer. I do get 6 exactly at -3/4 and at 4, and then the same intervals as well. So there we go. 2 different ways to solve that homework problem. If you got that correct, great. If you didn't, go through this video again as you need to and see